Okay, now we have done the bit manipulation part. Let's see why this is useful. Okay, so what exactly is I storing? I storing the bits of the number x, and what is, and how do we get that? That is equivalent to log of x, the bit representation. So we can say that I is equivalent to log x. Now let's see why this is useful. Let's say what is our entire aim of this? We have to calculate 1 by root over of x, right? Which can be represented as x to the power minus 1 by 2. If we take log of this, what do we get? Minus 1 by 2 log x. But what is log x? Where do we get log x? I. So what can we write? Minus I by 2. So our final result can be an approximate value of I by 2. But now think for a second. The whole aim of this was to avoid division, multiplication, division, subtraction, these kind of things. Mainly division. Subtraction still is easier. Division is extremely space and time complex. So we are still dividing by 2. But think for a second. I is now an integer number. Divide by 2 can be easily done. How? By right shifting. If we right shift by 1, we can easily get this. But what about the negation? To compute what exactly is being negated, let's take from the source I saw there, take lambda, let's take alpha equal to say 1 by root x. Okay, so log alpha equal to what? Log x minus log x by 2. Clear? Now what is log x? Or log x was finally computed to what? This thing. So log alpha will be computed to a similar thing. So what we can write? What we can write? Log alpha equal to 1 by 2 to the power 23 e alpha into 2 to the power 23 plus m alpha plus mu minus 127 equal to minus 1 by 2 into 1 by 2 to the power 23 e x into 2 to the power 23 plus mx plus mu minus 127. So now we just have to basically solve for the bit representations of alpha. This is what? This is basically this entire thing is a bit representation of alpha, right? So we can, if we further solve it, we will get something like this. I am sparing you the calculations. Plus m alpha is equivalent to 3 by 2 into 2 to the power 23 127 minus mu minus 1 by 2 mx plus ex into 2 to the power 23. Now what is this? This is a bit representation. So this can be represented as what? 1 by log x. So we calculated this as what? Minus x. This thing, x right shifted by once. But see this thing. This entire thing is a constant. And this constant is called the magic number, which was calculated to be what? 0x5f3759df. Now how exactly this was calculated? There is a discrepancy because most people say it was trial and error. Like this was calculated to be the most suitable value to find the result, and that is how this value came to be. There is no direct source of origin about why this exact number is the reason why this works. Yeah, there are a number of course, but yeah, this number gives the highest precision value for the result.